let's try that. Now can you hear me? Yeah, there we go. That's the other thing I was watching the video for. There's fucking particular settings on Zoom when I hooked up this way that require it to work. All right. Good. Excellent. Adding it. And I'm going to paste what we had earlier, and we're just going to go through some of the stuff. All right. As a reminder, there's different things we have, include IOStream. That allows us to input stuff and output stuff. We've had things like vector, which we probably won't work with today. What? I have no idea what the hell you're talking about. IOmanip, that was a good one. This one's a good one to include because not everything uses it. It's not necessarily assumed when you're using a program that it has it uploaded. Then we have int main void. This is main as a function. As a reminder, anything with something set up like this is a function. What's in parentheses is the input. So void means main has no input. Int says that it's going to return an integer. So at the bottom, we have return 0. I can change this to void main void and come down here, and now I don't need the return 0 anymore because the void with here now says it needs to return nothing. And we're going to take advantage of that with functions later on. We've got pointers going on here. Here, what are we doing? We're taking x. Yeah, let's make it a comment. Make x a variable. It's called declaring x as an integer variable. And we are assigning a value of 5 to it. The equal sign is a sign value. When checking for equality, we use the double equal as a reminder. And right there, that's not doing anything. It doesn't show the screen or anything like that. It's just assigning the variable. Is that fucking Discord blowing up? Over here just making noise, interrupted my shit. Okay, so when we want to do a pointer, using the asterisk after this is one way of doing it. Another way of doing it, it's not going to let me type it when I do it. It's not going to keep it that way, but you can put it right before the letter and watch what happens as soon as I hit space. It's going to move that. No, it didn't move it yet. There. Once I hit enter, it moved the asterisk. So this method works, but it's confusing because this method is also a pointer, but it's confusing because it's the same way we dereference, as we'll do in a bit. I'm gonna, like one was doing in Discord, everything I type, if I don't use it, I'll comment it out. I take it, I comment, I post it on Canvas. So when we run it, so this is just doing the same thing as this one. What's the ampersand do? Does anyone remember? That's what the and sign is. What? Yeah. The ampersand symbol says access the address, memory address of X. And so that's what pointers store. If you were in here in Juan's group, Discord, not Discord, his SI session, he was going over some of this. There's going to be a little bit of a repeat because not everybody was here for it. And it's good that everybody's had a month off and probably didn't do a goddamn bit of programming. It's easy to forget. So pointers point to addresses. So if I see out, when I'm going to run it in a second, when I see out X, let's see this, there we go. Now I can move around a little bit better. Ah, fuck it. Minimize the zoom bar. When I see out X, what does see out do in general? It prints it to the screen. If we want to do it to a file, there's other ways to record it to a file. I don't think we do that in CSCI 1, do we? I think that's the end of CSCI 2. We will show you how, by the end of this semester, how to, instead of print to screen, print to file, and how to upload from file. And that's way you can do databases and shit like that, not just have shit that only runs once and then you're done and it's gone. That sucks. Why do all this shit if it's gone when you're done? Let's just hit run and compare to what we have on screen. So X was 5. Then we're doing a C out of X. It's printing the value of X to the screen. When we do with the C out of with the ampersand, it's doing the address. This is the hexadecimal. Let's do this. There we go. This shows the address as a hexadecimal, which is 16-digit numerical code, or not necessarily numerical code, but 16-digit code. Number base. X pointer, when we do a C out of X pointer, what is it doing? It's also, since X pointer was storing an address, it's giving us the same address. And when I put the asterisk in front of it here, this dereferences, which dereferencing means return the value stored there. So that's what the asterisk in front of it's doing. This should all just be a refresher, depending on how much you paid attention during the pointers talk in CSCI 1. Any questions so far? All right. I'm going to comment that all out. If you're using Visual Studios, it's got some handy shit going on. If you want to comment a block and do a whole thing, you hit this, comment the selected lines. And if you want to reverse that, you just do the button right next to it. If you're using some other IDE, I don't know what to say. This is the only one I use. So I'll comment it out. It's handy. So what if we do something else? Let's close that and run a different one. Run it again. Feel free to ask questions anywhere along the way. We'll stop and explore, play around with some of the stuff. This is an array as a reminder. There's a couple ways of dealing with arrays. Arrays, the size needs to be pre-declared. And we have a couple ways of doing this. We can set it equal to something on declaration. Or we set the size by putting the value in the brackets. So I could have char XX bracket 5. The value or the size has to be fixed. You can't change it within the program. So if you wanted to say int y equals 6 up here and say this is size 6, it should give me a problem. Oh, not 6, y. Nope, there we go. Notice that nice thing about Visual Studios, some of the other IDEs have it, I'm sure. If something's wrong, it's got a little underline. Y is not a fixed value here. So if I try to run this, it's going to break. But I can change that by making Y fixed by giving it the const thing. So const is short for constant and fixes the value, making it immutable. You can't change it. So now I could do it. You know what? I'm going to go with 5. I'm going to go XX equals Hefe. Oops. Why is that upset? I wasn't changing the size. Are you not acknowledging? What am I missing here, Juan? What the fuck's gone wrong here? That should have worked. Yeah, we can do it all in the same line like I was doing up here, but you should be able to change the value of the array with it being fixed. Y is fixed at 5. This has 4 letters, and then character arrays end with the shit. That's fine. You should have been able to do it afterwards. If I had it. This is how you change values of particular things one at a time. So we have 2 arrays here, the A array, the double X array. A, like I had terminated by this. I actually had that up above. So A is actually, A is 6 digits or characters long. And Hefe is technically 5. See out A. See out XX. Get a little bit more stuff in there. So I run it when I run it. What? It doesn't like how I terminated it. Does it want me to say 4 here? That shouldn't work. No. That's fun. Let's go back and look at that later. That's shit I added, and something's wrong with it. We have the David array. Comment that out. Commented out X. And we saw when we ran it that it was just showing David to the screen. Right there. And we come along and we declare this a pointer, APTR is short for pointer. When you're doing an array, we want to direct it to the first character. And so that's what we did with a pointer. I've got C out A there, so I don't need this one. When we do there we go. So we did a C out of A, we've got David. When we do C out, we're telling it to start at the one element in the array. And the first element is 0 where D is, so the A is at, well, maybe I should, that's confusing because the whole array is called A. I'm going to change this to Hefe. That way we don't have A's showing up everywhere. There we go. So we got Hefe going on. It's pointing to the first character, or A pointer is pointing to that. We do a C out of A right here on that line. When we tell it to C out starting at 1, we're telling it to start at the second character because arrays start at 0, not 1. And notice it shows the whole thing. When I tell it to C out a pointer, it actually showed Hefe again. So a pointer was Hefe again. I'm going to come up here and uncomment this out because we had this here. Actually, put it back. Unblock it that way. Yeah, I will. I will. So I'm going to rerun it real quick because I want to point out something. When we did a C out of X pointer up here, which was the third line, it gave us the address. When I did a C out of A pointer down here, it didn't give us the address. It gave us the value in the array. So there's a difference between doing arrays and regular variables. When you do pointer, when you see out a pointer on an array, it actually shows what's in the array. When you see out a pointer to a variable, it shows the address of that variable, not what the variable is. Okay, so this is a big difference. When we do a C out, or when we use the pointer for an array, it's accessing the value, not the address. Now, when I tell it to do C out integer array, what this is doing is a pointer is a hexadecimal. It is still an address. It's still an address. If I want to do integer value, this tells me it takes the hexadecimal value. That's a little hard to read. People don't like, we use a 10-digit code, base. 10-digit base. 16-digit base is confusing for people. So if we switch to integers with 10 digits, that's the access of memory. And it's showing us the address. If I do a for loop, this is a reminder of a for loop. You need a start, you need a stop, and you need the increment. On for loops, you need start, stop, increment. We could do this int I beforehand. And change this to I here. And it's going to work just fine. But it keeps that integer I in memory at 0 for the rest of the entire program. It's kind of wasting memory for no fucking reason. So like this works, but we're better off not doing that. If we have it in here, the I goes away as soon as the for loop's over. It gets rid of it. So that's good to know. And then as we're going through this, notice Hefe. You know what? I'm gonna now. Yeah, I'm gonna move this down here, which had this with it. There we go. Now we can see it all on screen. Hefe is only 4 characters, even with the terminated point or value. It's 5. This is telling it I equals 0 to less than or equal to 6. I equals 0 to less than or equal to 6. This is why I brought my little camera here. What? Oh, shit. Thank you. I'm telling it to access 0, 1, 2, 3, 4, 5, 6. Don't need that. And you can see Hefe should be like this. So WTF, what the fuck is this? Junk right now. But when I'm doing a C out of the address, it doesn't matter. If I instead tell it to do C out of AI, I'll throw in another end line so it shows it better. Now it's getting all confused. Oh, I need to, it's the negative shit's acting weird. Let's do a deep reference like that. Why is it giving me, oh, it might be, why is it giving me a negative value for the address now? Okay. Notice afterwards, it's just got junk. This is the E, this is the, it's showing everything after that value. We get on to FE, this is E, this is the null termination. And now we've got junk characters. So, but if we ignore that, it doesn't have a problem just doing all the characters or all the addresses one in a row. That's fun. What if we do a C out of a pointer? Can I do this? I don't know. Let's find out. What? Didn't help. It's actually going through and showing each letter one at a time. Because a pointer up here shows the whole name, it's still got junk. If I do the integer value of the pointer, it doesn't have a problem the whole way. It's doing the J, showing me the integer value. Showing me the integer value of the character A or J, integer value of the character E. That's fun. Was not expecting that. I had in my head that was going to be the address. That's not. This is the ASCII value for the character for the letter. If we want to get the actual address, I need to dereference pointer I. That should do it. And I'm going to get rid of one of these endls. Doesn't like it. There we go. So now J, the ASCII value of J is 106, and it's doing the memory. Characters chars are one memory byte each. Right? Notice if I do like a double array, we up above we assign an array with a character right away with a string. If you want to do it with something else like this, you use the curly braces and tell it what you want to do. Maybe we'll skip 5, go to 6. Let's see, that's 6 characters. And we want 7, so I'm going to add another one. And I'm going to copy this down right here. And I'm just going to change this to say Z. And let me comment out this. Oh, no, we'll leave it. What happened? Why did... One, two, three, four, five, six, 7. That's 0 to 6 is 7 boxes. What about it? Why? It when by telling it what's in it, it has the value. It knows the size. Just like we did with the string up here with Hefe. If you give it assign the array the value, it should have been fine. Let's see if... Oh shit. Never mind. I guess I'm fucking wrong. God damn it. Okay, here we go. So it's got the 1.1. It's showing what is, I got the same thing written twice. That's fun. Oh, I didn't make a pointer. I wanted to do a pointer dizzy. Let's do double pointer. CPTR equals its address is Z0. And now I'll use CPTR. And that might buck up. No, that's gonna work. So we're doing the numbers. Now we can go through the numbers. There was a reason I wanted to do numbers versus characters. And what was it? Oh, I was showing memory. Yes, that's what it was exactly that. I was showing memory. Thank you. So notice when we get down to the net. Okay, let me put some more spaces in here between these. You know what? Let's be smart. Why type that shit when I can copy paste? It's to retype everything. Ren's a fool. Ren just doesn't like video games. I mean, can you really trust a CSCI instructor that doesn't like video games? That's like an English teacher that doesn't like reading books. There's something wrong with it. What? That actually happens a lot. Yes. A lot of alcoholics, when they quit, like serious alcoholics, when they quit, when they've got enough time under their belt, they have a lot of experience with drinks. And so it's a good job to do, and it keeps them sober. You'd be surprised how many bartenders are sober. But I liked where you're going with it. Yeah, so the character array memories were going one by one, 136, 137, 138. When we're doing the double, 232, 240, 248, 256. The double, each one is 8. Eight bytes. Yeah, wonder why. Oh yeah, it's chopping. Notice it rounds down when you chop too. It doesn't round. This is not a rounding thing. Yeah, this for the numbers, I didn't really need that for this one. Get rid of that noise. A little easier to see the hot bytes. It's weird watching it go this way because it's got negative numbers, so it's still going up by 8. Okay, so this stuff's all fine and grand. I want to point out something right now. This is only working. The for loop is only working because this is an array. When I am doing the address part. Adding one is just getting the address of the next one. You'll see when we do other stuff when it's spaced all over the place. Actually, I was doing 1.1, 2.2, 3.3, 4.4. Let's take a look at when we're doing stuff like that, seeing what's happening. Or talk about what's happening. This part here is called pointer arithmetic. So I'm going to comment out everything above it for now. Rerun it. I did not comment out the 5 at top. Uh-oh. What did I do? What the hell? Undo. Where are the... Did I need X later on for anything? No. I should have been able to comment that out. It shouldn't cause a problem. Okay, there we go. All right, so we got our array 1, 2, 3. And now we've got a pointer for B that's pointing to B. When we do C out B pointer here, it's showing the address. I was wrong earlier. I said it was the array thing fucking it up. It's not. It was the character part that was fucking it up. Because when I do C out B pointer is the address of B. This here saying equals B is also the same as saying address of B bracket 0 is the same as B in this scenario right here. Right. There's no char. It doesn't work like, yeah. It's the char string thing. Where was I with this one? Okay, B pointer B gives us the address. We can dereference to get the value there, which is the 1. If I do B pointer plus 1, it's giving me the next you know what? I don't like this address as a hexadecimal. Let's cast it as an integer. What does that do? What? Well, you didn't finish this thought. I need a full question here to answer it. Well, we're put, this was the integer part is just taking, let me do it without the integer part so you can see the difference. B pointer right here. Fuck. Quit blowing my shit up. Someone on Discord. Yeah. There we go. I got, yeah, the fucking beeping distracted me. The B pointer is showing the address as a hexadecimal. That's not really all that readable to most people. So this is taking it and changing a base 16 to a base 10. What? It wasn't, yeah, it wasn't active at the time, but so that's an interesting question. Why were some of them negative? No, that's not how it works. There's a reason why it goes negative because it takes less digits. Think of doing 100 and going 0 to 100. Going up to 100 now has 3 digits. If I do negative 50 to 50, I've only got 2 digits. It takes up less memory. It's decision, not like that less memory, but like it's more tolerable of it when like if they do half negative, half positive, then it's like happier for like I don't know. I don't make the hardware of it, so it's related to that though. It's better for the system to have the negative thing. When you do unsigned, I'm pretty sure it's just shifting everything automatically, but it right. Huh. -5 to 5. This is single digit. 0 to 10 goes up to double digit. That's that idea. Uh, and doing unsigned, this just shifts them all to be positive. You may be like, oh, like, how is that different? Well, when we're reporting the address of it like that's using memory all of it its own as well. And that memory is lessened by using one less digit. The memory of the memory that we're this is some fucking inception shit going on here. There's a lot going on with that. Okay, so but unsigned works. It makes it all positive. It actually is makes it more readable for people. That definitely helps. So we had that. This makes it a inner or the integer address. And then we're doing this dereference to get the value of B0. So getting rid of that part right here. Let's rewind this with that. I learned that shit, the -5 thing in grad school. Because I remember one of us asking why. And it's literally, it's one less byte, basically, because bytes are done, it's binary. So it's chopping the number in half takes one less binary 2, 0, or 1, basically. Where are we here? So we got one. This is this is my. I'm gonna move this over so I can see the. There we go. So 86. Yeah, yeah. It's where it's storing it in your memory. No, like it's where it's the physical address in memory, and yours is pointing at a different spot in memory. Your memory is a fixed size. Okay. Wherever you had it, let's say it's in this block right here. And let's say on mine was up here. Yours is it's giving you the hexadecimal address of this square right here. And on mine, since it's stored in a different spot, it's giving you the hexadecimal address right there. It's like different page number, basically. And I'm pretty sure if I run it again, it's going to be in a different spot altogether. I got 400 there. Let's close this and rerun it. And it's in a different spot. Every time I run it, it's storing in a different spot because that spot's now the most free. I don't know. I don't know how it picks how it stores it. Right. Yeah. So it's like, it's where it's storing it right now on my laptop. And if my laptop, we could, by random chance, get the same address one time to post, but I find that shit highly unlikely. Mine doesn't do the 0x, so is that the Mac thing? Okay. Because I don't have it on mine, so. All right. Where were we? Okay, so line 86 is doing out the address. Sorry. Doing out the address. Then we have the doing it as an integer. Then we've got dereference B0, which gives us the 1, which is right there. Then line 91 is this next line is the address right here. So this +1 is saying go to the next spot in memory. And this is saying dereference the next spot in memory. Okay. The bracket and what? The difference between 91 and 92? 91 is giving me the address of 2. 92 is giving me, it's dereferencing the address of 2 to give me the 2. You know what? Let's use different numbers here because I think 1, 2, and 3 is obviously adding 1 makes it sound like I'm adding 1. So doing 2, 5, 8 might be more helpful. Let's do that. And I broke my shit. There you go. Okay, so now looking at it, 90 is dereferencing the first cell of B, the first box of B, giving me the 2. This is giving me the address of the 5. This is dereferencing the address of the 5 to give me the 5. And having the 1 and the 2 made it look like I was just adding 1 to it, but it's not. It's literally moving, going, okay, here's the address of 1. This is the address of the 1 after it, and let's dereference that value. Is that cleared up a little better? Yeah. Dynamite. All right. And we can see here it's doing that right there. What and it's like here it's got the let's change this to uh integer value right here. Ooh, it's doing fucking override. I hate fucking override. Yeah, it seems yeah. Insert toggles between override and not override. No, that's what I hit when I fixed it right now. That's fun when you're trying to fucking find it the first time. You know, because then when you fucking type it, you're typing into Google and you fucking mistype. You can't. You have to. Yeah, it was bitch. Once you know it, you're like, I know that shit now. Now that fucking Aaron pointed it out, I'm gonna fucking fixate on. Thanks, Aaron. Thanks for ruining my fucking. Have what issue? Yeah, yeah, yeah. Right here, closing that and pinning it basically. Yeah, you got to go. It's view, I think. It's right there. The first time you're doing, you're like, where the fuck did my code go? So when you first start, every first time user, like your first time programming, you're a total rookie. You fucking accidentally close this thing. Right. Yeah. It's based off what it's pointing to. So the array thing, well, for the arrays, it's always going to be the same. It should be the next cell block, depending on however many bytes this thing takes up. That's how much the address is going to change by. You're going to see later on, and Juan talked about mentioning this, how excited he was to get to it. Not today, but on Monday, linked lists. When we do linked lists, shit is stored like, oh, I use 2, 5, and 8. 2, then our next memory spot is over here. 8 might be over here. And trying to do the for loop with regular +1 doesn't work as well unless it's a pointer. And then doing the pointer +1 says go along to the next point. So using the pointers is better than like passing by value kind of thing. Yeah, yeah, they're not. It's called. It's a weird word. It's called contiguous memory. It's I don't know why they don't just say continuous memory, because to me that would mean like it's all connected. Contiguous means they're all right next to each other. It's a fucking weird word. I hate like it just sounds tainted in my mouth. What? Yeah. It's like yeah. It's like you're if you're playing hopscotch and shit like oh god, that's a fucking has anyone in here played hopscotch? This is fucking wow. I guess yeah, I guess for kids it's something kids do. What? Well, you're not that young now. You're I mean like young as uh in reference to my age. Like you guys might think I'm old as fuck, but like compared to, I don't know, Joe Biden, I'm fucking hella young. You know what I mean? Age is relative. Your youthfulness is relative. All right, back over here. So let me rerun it, make sure I haven't done any fucking edits. All right, so we've got, it's telling us the integer address of this, and it's dereferencing to show the values right there. What did I want to say? Okay, this is what I wanted to do. Thinking you can use ChatGPT. I don't know. Everybody learns differently in this. This isn't like mathematics where I could easily answer that fucking right away. Negative sign. As soon as you got negative, in fact, that's probably why Aaron went, well, let's do unsigned in. Negative signs just fucking fuck everything. They're important, but like once you introduce them in mathematics, you make more mistakes with negative signs than anything else. Here, a little different. What do you guys think is going to happen when I run this now that I got rid of the parentheses? Because the one with parentheses, with the line 5, oh, that's not line 5. I'm missing the, there we go. Line 95 here is doing that. Maybe I'll add another endl there so that when I run it, it looks different. Yeah. Yes. So notice when we run it, it's not going to change. It's not going to hop to the next memory spot and get the value there. It's going to stick with the same memory spot. The original one had 258. The second run with it out the parentheses is doing 234. It's adding I to the first value here because that's what this is doing. This is dereferencing B pointer, which points to B0, and then it's adding 1. Here it's going, where is B pointer, and adding that to go, okay, let's go to the next pointer spot. And that's why it's called pointer arithmetic. This first one here is pointer arithmetic. For the value. And the second one, this one is just doing arithmetic on B0. All right. And that's what we got for that one. I've got another one I want to run. Oh, that. Let me comment out all that because I'm going to copy and paste this all. Come over here. Let's grab the other one. Much shorter. It's doing a little bit of a review on functions. Just doing arithmetic, adding. Yeah, it got the value of the first spot and then just did the basic addition. All right, so Juan was starting to do a little bit of this stuff too. I've got 3 functions here. Square fun is short for square the value function. Takes in an integer, returns an integer. Function 2 takes in an integer by reference and returns an integer. And taking function 3 takes in the pointer for an integer and returns the integer. So if we say int x equals 5, we make a pointer for x pointer saying the address of x. And when we do it, this function 1 will not modify the value. So when you pass in a value, let's just run it and look at it on the side. We passed in a 5. This one, square function 1, you know what? I'm going to do this. This is David being a clever girl. That way it's, you can see it right on screen. This one's taking an integer, returns an integer. We passed in x. If I go down and look at what that one does, it takes x, which is now pass here. It said, let's make result equal pass times pass, which is effectively squaring it without using the C math library. Why load a new library if you don't need to? It says pass equals 10. So like here, when pass came in, pass was 5. And now I'm saying pass equals 10. I return result, and the result it's printing out is the 25. So the 5 squared. Yeah, that's what I was saying. That's why I commented all this out so that I could copy and paste it all to Canvas. It's okay. If you didn't hear it, you didn't hear it. It's fine. Then this line right here, line 23, says X after function call and is returning the value of X. Notice X is still 5. When we pass by reference, look at the difference between these two functions. This code block is identical to this code block. The only difference between these two things is the pass by reference, okay? When we pass by reference, so they're both getting pass equals 5 here, sent in, and they're both saying pass equals 10 before it's done. When we run it, it's still giving us the 25 squared, but now it's modified X in the main. So when you pass by reference, passing by reference can modify the value in the main. Yeah. Oh, you're just, I mean, okay. When we pass by pointer, similar thing happens. Now notice here at this point, recall the last bit changed X to 10. So X pointer is pointing at the address of X, and X has been changed to 10. So that's what's getting passed in, the address for X equaling 10. This code is a little different. To use the when you pass by pointer to a function, you have to dereference it. We didn't have to do that here when we pass by reference, but we have to dereference when we pass by pointer. This is obviously easier to remember and easier to code. You don't have to, like, it's a far less pain in the ass. But it doesn't work when we're doing shit like linked lists. Okay. So you're better off having, like, when you're working with pointers, get used to working with pointers. I know you didn't do a lot of it in CSCI 1. So that's why we're going to do this like entire semesters, like almost all pointer shit. So that's kind of neat. So we were taking in 10 here when we brought it in. And it was about pass. This brought in the address of pass equals 10. Then we dereference it here. This is giving us 10 times 10. So result is 100. We're returning 100, but now we're going to say pass equals 20. The dereference pass. Pass was a pointer here. We're saying 20. So like X equals 20 here now in the main. And we come up here and look at it. We send it in. The 10 gets squared up to 100, and X has now been changed to 20. So both passing by reference with the ampersand or passing by pointer with the asterisk modify values in the main. And modify it can change all that shit unless it says constant in it. There, I'm gonna, because this is like a big red flag that you fucking cheated. If you've got const on every fucking thing, I'm just gonna assume you fucking cheated. Because there is no reason to use const unless you need to guarantee something's not changing. I see it all the time where I will see void function integer or online reference or like go anything. There is no need for this. This had this had nothing to do with what you said. This is me still teaching.
Oh, I was, okay, I thought you meant like what I said, like, I like something like copy and pasting in allowed or something.
You can copy and paste, but you can't copy paste from sources you didn't use
That was,
or you didn't make.
I was like, say like,
You know what cheating is?
yeah,
Using work that is not your own, right? That's what I mean. However you do it, even copy paste is the shortcut way of doing it. But if you have AI do it and you manually type it in, you're still cheating, even if you didn't copy paste.
copy and paste too. Oh, you just copy and pasted this back here.
You've seen watch me copy and paste in this. Like copy and pasting your own shit works. That's it. You don't be sorry. I just want to make it clear. Copy and pasting your own stuff works. Copying and pasting shit that is not your own stuff doesn't work. That's cheating. You all know what plagiarism is. This isn't a big mystery. This is a red flag because whatever the hell this is, whatever this function does, why do I need to make sure this is constant if it's not doing anything or not changing anything? It's not returning anything. There's no reason to have this as a constant. It's I see it all the time. Const. What the fuck? Like, why? Don't do it. Just type code normally. If you need a constant, make a constant. Uh, very few reasons to force something to be a constant. One is fixing an array size ahead of time and using a variable to do it, like I had up there with the y. Another good time to use a constant is actually before. I'm going to comment that out. Oh, let me put, since I'm going to copy and paste this to Canvas. Don't do this. Idiocy. That's how you spell idiocy. Yeah. There is a reason to use const. If I do like const double, pi is a common one, 3.141592653598885. I'm going to stop there. Let's just stop there. He's got more digits memorized than I do. I go up to 9 and stop. The only reason I will remember 2 6 sometimes, only because I saw it earlier. Did I remember it? Doing this, we don't want the value of pi to ever change. This is called a global constant. Global constants are constants declared before the main. They should be used sparingly. There is no reason to declare variables before the main unless you're going to make them constant. You might as well put them in the main.
Because I've seen, well, at least for me, it doesn't work whenever I put const at the beginning of I'm using Xcode.
That might be the way Xcode takes the command. I don't know. What do you mean by like at the end, like putting pi or double const? I don't know. Let's see what happens when it does it. It worked. You learn something every day. I'm surprised Xcode doesn't allow it the other way.
So, well, it's for my code, because the ARM builds aren't the same.
Hold on 1 second. 1 second. Monday's a holiday. Don't forget. Wow, you're already fucking tired of seeing me? That's cold. It's been 2 days. Jesus. Shit. You're in for a long fucking semester. Yay. Right. All right, Irving, what were you trying to say? I wanted to make sure everyone knew Monday was a holiday. Irving, what were you trying to say?
Build, arm chip build, mobile chip build.
Okay.
And I have to look it up. So it does work with it. The issue is that for some functions, let's say something large, some sort of large function. When you put the concept beginning of that function, it doesn't want to make it work. You have to put it after, like it's a double const, that's how it works. The issue is that actually read and figured this out too last semester, that people that are caught cheating have cons after like the double or the in or anything like that, because AI for some reason prefers that too.
Okay, the appearance of const by itself isn't the red flag. It's the abuse of it.
Yeah.
Like there's no, if it's not going to be changing, you're not passing by reference. We just saw functions don't change the values, so there's no need to worry about returning a constant because it's not changing anything. But it's like one of the things I see. Let me hit stop record here.
It's kind of just a weird funky thing that happens with text.